Hello and welcome back to Getting Started with BGFX. So in this video we are going to be making and using a frame buffer. Now a frame buffer is like a virtual screen inside of your computer. So instead of rendering to the physical screen, you render to the frame buffer. And then the frame buffer can be used later on to render to the screen, the physical screen itself. And this is useful for when you want to do something like post-processing. You'll render your entire scene to a frame buffer, and then you can just use the frame buffer as an ordinary texture to draw to the screen, and you can do some post-processing, which we will do later on. Now a frame buffer is made up of one or more attachments. So in our example we are going to be creating a frame buffer with a color attachment, which is all the things you can see in our scene, and a depth stencil attachment. We'll get into depth stencil in another video, but for now let's dive into the code and we'll make a frame buffer. Now before we get into creating a frame buffer, I just want to fix something from the last video. As you can see in our example here, we've got the texture that we loaded from the drive and we're rendering it to it, but you might notice that the statue is facing to the left, but in our actual texture the statue is facing to the right. So to fix that, what you can do is just change the texture coordinates. So we'll go into our renderer class, and we'll go down to our draw image function, and all you need to do is just change the zeros to a ones and ones to a 0, like so, and we'll build this. And there you go, now it's facing the right direction. Alright, let's get to making our frame buffer. First thing we need to do is we need to make our header file. So we'll create a new header file, add new item. We'll call this frame underscore buffer.h pragma once, include the BGFX header, then we'll create our frame buffer class, do the constructor, it will take in a width and a height, we'll do the destructor. Then we'll create a function to return the frame buffer handle, because we're going to use this in our viewed. We need the handle for our frame buffer to tell BGFX this is what we want to draw into. So get frame buffer handle, and we will return m underscore frame buffer handle, which we'll make soon. And finally, and not finally, also need to get our color attachment handle. So remember, a frame buffer is made up of one or more attachments. The color attachment is just what we can see, and it is just simply a texture. Okay, now that we've done that, we'll create frame buffer handle, frame buffer handle. We will do a texture handle for our color attachment, and also need another attachment for our depth stencil. So again, we'll go into depth stencil in another video. Alright, now we just need to store an array for attachments. Alright, now that we've done that, let's create our source file. There's an error. Oh, I've got the semicolon. Don't forget the semicolon. Alright, create a new item called frame buffer. .cpp. Alright, we'll include our frame buffer header. First thing to do is we'll do our constructor. So this is where we will build our frame buffer. So we'll take in the width, take in the height. First thing to do is we'll create our color attachment. This is just going to be creating a texture. So create texture 2D, give it a width, give it a height, no MIPS, one layer, and we need to give it the format. So the format is just going to be, has red, green, blue and alpha, and has 8 bits each. So we'll go texture, format, RGBA 8. And finally, we need to tell BGFX, we need to give it a flag saying that this is going to be a render target. So we'll go BGFX underscore texture underscore RT, short for render target. If you don't do this, we can't draw into it. Alright, so what we can do is we can just copy this. So this is going to be our depth stencil attachment. But the format is going to be different. It's going to be D24S8. So what that means is that 24 bits is reserved for the depth and 8 bits is reserved for the stencil. So again, get into depth stencil in another video. But what we need to do now is go BGFX attachment. We need to create an attachments array. And the first attachment is going to be our color attachment. The second attachment is going to be our depth stencil. You don't have to limit yourself to just 2 attachments. You can have multiple color attachments, for example. That is a method that's used for when you want to click on the screen and you want to read the ID of the entity. You want to see if there's an entity there, so the ID gets rendered as a color in a second color attachment. So it's a pretty clever way. Look that up. That'll be a challenge to get that done. So now we create the frame buffer itself. Create frame buffer. We give it 2 attachments. We need to give it the pointer to our first attachment. And destroy textures true. Okay, so when we destroy the frame buffer, which we'll do in, that is initialized, we'll do in the destructor, it will destroy those textures along with the frame buffer. So now we'll do the destructor. And we'll just destroy the frame buffer. And there we go. Now I just realized that we don't actually need this part, because just do it up here. All you need to do is do it like this, do that, pass it into there, and you're golden. Alright, so now that we've done that, what we need to do now is we need to go into our renderer. So we need to open up the renderer header file. Need to include our frame buffer header. Now down here we'll have a variable for frame buffer, m_frame buffer. Now inside the renderer initialize, at the end of it all we'll do m_frame buffer equals new frame buffer screen width, because we want to render our entire scene into this frame buffer, screen height. Alright, now that we've done that, so what we need to do now is we need to tell BGFX we want to use this frame buffer to render into. So we'll do this by going BGFX set view frame buffer 0 m_frame buffer get frame buffer handle. Alright, now that we've done that, let's run it. And nothing, and we don't see anything anymore. Very good reason for that, and that is because we've told BGFX that we want to render into our frame buffer, but from there what we need to do is we need to use it, and what we can do is just draw this to the screen like any ordinary texture. So to do that, first thing we need to do is we need to create a separate first thing we need to do is, remember in the previous video, normalized device, the screen uses what's called normalized device coordinates, where it goes from -1 to 1, no matter how big our window is. Now, since our frame buffer is the same size as our window, we can use normalized device coordinates, because the frame buffer will go from here, which is x of -1, over to here, which is x of +1. So we can just use ordinary normalized device coordinates. We don't need to set any transforms or any view projection matrices or nothing like that. So the first thing we need to do is we need to create a special vertex buffer for this. So first thing is we'll go m_ndc vertex. We need the first vertex buffer handle, and we'll call this m_ndc vertex buffer. And now we'll go into our initialize function. So we'll create a vector of vertices, so vertex, and we'll call this, actually no, what we need to do is need to put this here, this m_ndc vertices. Alright, now that we've done that, we'll go m_ndc vertices dot pushback. So the first vertex is going to be at -1.0, 1.0, so the top left, and 0.0. Then give it a color, it's going to be white. 1, 2, 3, 4, yep. And finally we give it the texture coordinates. So this is going to be 0.0f, 0.0f. And we'll just copy all that down. So the next one's going to be the top right. So this is going to be 1, 0. Then it's going to be the bottom right, so there. And it's going to be 0, it's going to be 1, 1. And finally it's going to be -1, -1, that's the bottom left, and that's going to be 0, 1. Alright, so now we'll create the vertex buffer itself. Creates vertex buffer, and do the same thing as we did before. We need to, what we'll do is we'll make a reference to this just in case we want to change it. We want to keep these vertices just in case we want to change the size for whatever reason. Maybe we want to make this a mini map inside the game. So we'll go make ref m_ndc vertices.data, then size of vertex multiplied by how many vertices we have. So just to make this very robust, we'll go vertices.size, and it's going to be the same vertex layout as we've done before. Alright, so what we'll need to do now is we'll go down to where we draw everything, and first thing to do is we need to set our vertex buffer for view 1. So first thing is set, not sure why my IntelliSense has crashed. Alright, so set vertex buffer m_ndc vertex buffer. Need to set our index buffer, and we can just reuse the same index buffer we've done before. So m_index buffer 0.6. So we're starting off at index of 0. We're using the first 6 indices, so that's just to make a quad. Now we need to set our texture. So BGFX set texture 0. So this is in the first slot, m_uniform. Then go get the color attachment from our frame buffer. And finally we'll submit it. So we're going to submit this to view 1. So view 0 is where we draw everything, and we're drawing everything into our frame buffer. View 1 is where we are presenting it to the screen, so drawing it to our window. And we can just use the shader program that we have, because this is just an ordinary texture. So we can use the same shader we've been using for all of our textures. Handle. Alright, first let's build this to make sure there's no errors, because the IntelliSense has crashed. And yes, there is. What have we got? Nope. And there needs to be a bracket there. And we've got too many other brackets down here. Now one last thing before we run this, we need to go up to our begin function. We need to set the view rect and view clear of our new view. So we need to set it to view 1. So we need to set the view rect, so set it to our whole screen width and height so we can see everything, and we need to clear everything. Alright, now let's run that. And there we go, we can see everything. So what we're doing here is we are rendering everything to a frame buffer, and then we're taking that frame buffer and we are rendering it to our window. Now just notice everything's got a slight blue tinge, and there's a very good reason for that, because our clear color is the aqua. So if you set it to white, there we go, nice and clear. So what we'll do just for fun is I can never remember which way this goes. I think this is the red. So we'll cancel out the red. Nope, goes the other way. Yeah, sometimes it's this way, red's here, other times red's over here. So if you can't, oops. So what we'll do is we'll just change this one. So this cancels out the red. So that means when we're drawing everything to the screen, all the red is zeroed out. And there you go. Or we can go the other direction. We'll cancel out the green and the blue, so we're only left with the red. There you go, so we only got the red. So this is post-processing. So it's taking everything we've rendered into the scene, and it's applying some very basic post-processing to our scene. So what we'll do in later videos is we'll use IMGUI to change this color here. So that'll change the post-processing color. Alright, so that's it for this video. In the next video we are going to get into the depth stencil and alpha blending. So I will see you there.